Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of the January 2018 Algebra 1 New York Regents exam. Alright, let's take a look at question number 11. It reads, the expression negative 4.9t squared plus 50t plus 2 represents the height in meters of a toy rocket t seconds after launch. The initial height of the rocket in meters is... So before we get started with the problem, let's go ahead and write down the formula that helps us determine the different components of a projectile motion equation. Okay? So formula for projectile motion. So projectile motion is basically a motion of an object that's thrown or launched into the air somewhere in the earth. Okay, so for example, in this case, a toy rocket is launched into the air, so the toy rocket is basically the projectile that gets launched. Okay, and what happens when you launch a projectile close to the surface of the earth, the distance of the object from the ground when graphed against time creates a projectile motion quadratic function. Okay, and that is given by y equals 1/2 a t squared plus v0t plus y sub 0. Okay, now what do the different components of this equation mean? Let's start with y. Y represents the height of the object from the ground at time t. Okay, so height at time t. And then a represents acceleration due to gravity. V sub 0, this sub 0 basically means initial. Okay, so V sub 0 means V stands for velocity, so V sub 0 is the initial velocity. And then we have T. T basically represents time. In this case, in seconds. And then y sub 0, remember y is height at time t, right? But y sub 0 represents the initial height. Okay? Where was the object before it was launched into its projectile flight path? That's what y sub 0 is. Okay? Now what we're going to do is we're going to rewrite this, write down the function that we were given. So let's go ahead and write it down. It's y equals, I just put the y there to express this as a function, negative 4.9 t squared plus 50t plus 2. So what I'm going to do is I'm going to write down this projectile motion equation underneath it, and then with the use of coefficients, we can determine what the initial height is, what the initial velocity is, and what the acceleration is. Okay, so let's go ahead and write down the function here. So we have y equals 1/2 a t squared plus v sub 0 t plus y sub 0. Okay, so if you pair it up, you can see that negative 4.9 represents half of the acceleration due to gravity, which is negative 9.8 meters per second square. V sub 0, the initial velocity, is the coefficient of t, which is 50 meters per second. And then what we're asked to find is the initial height. Initial height is y sub 0. Initial height is the constant. Okay, so y sub 0, the initial height, is given by the value of 2 meters. Okay, so let's go ahead and write that down. The initial height y sub 0 is equal to 2 meters. Okay, answer to question number 11 is option number 2. All right, let's take a look at number 12. It reads, if the domain of the function f of x equals 2x squared minus 8 is the set negative 2, 3, and 5, then the range is... So to answer this question, you need to remember what domain and range represent. Okay? So let's refresh our memory real quick. Recall what domain and range are. Recall domain and range. Let's start with domain. Okay? Domain, also known as a set of x's. Okay? Um, what is a domain? The domain is the set of input values. Okay? Is a set of input values, or the x's. Okay? And guess what range is? The range, also known as the f of x's, is the set of output values, is a set of output values. So you use the range, they take the domain, input it into the function, and what you get is the range. All right. So let's go ahead and use a table, an in and out table, to generate what the range values are. So let's start with x. What is x? Domain or range? X represents the domain or input. Okay, so don't forget that. So our domain x are the elements negative 2, 3, and 5. Now to generate the range, or f of x, we're going to use the function rule 2x squared minus 8. Okay? So let's start with the first one. F of negative 2, the first output, is 2 times negative 2 squared minus 8. We're going to use our order of operations here. Please excuse my dear Aunt Sally. Do the exponent first. Negative 2 squared is positive 4, sorry. Minus 8, which is 2 times 4 is 8 minus 8, which is equal to 0. Next, range value, f of 3, is 2 times 3 squared minus 8. So we have 2, 3 squared is 9, minus 8. 2 times 9 is 18, minus 8, 10. And then lastly is f of 5. 2 times 5 squared minus 8. And we have 2 times 5 squared is 25, minus 8. 2 times 25 is 50, minus 8, which is 42. Okay, so our range values is the set 0, 10, and 42. Answer to question 12 is number 3. All right, let's take a look at question 13. It reads, which polynomial is twice the sum of 4x squared minus x plus 1 and negative 6x squared plus x minus 4? All right, so we're going to do a real quick vocab review. All right, so certain vocabulary terms you want to keep track of is twice. What does twice mean? Twice basically implies multiplying by 2. Okay? Sum is the operation plus, right? So we add. Now, if I ask you to write an expression for twice the sum of x and y, what is that going to be? Twice the sum of x and y. Now, what you want to keep in mind is this expression is written kind of sort of in reverse order. Twice the sum of x and y means you find the sum first and then you double it. So the correct way to write this is 2 twice the sum of x and y, 2 times the quantity x plus y. Okay? So let's keep that in mind. Let's extend that to this problem. We want to write the expression for twice the sum of 4x squared minus x plus 1 and negative 6x squared plus x minus 4. Okay, so to write that, we're going to be doubling what we get when we find the sum of 4x squared minus x plus 1 plus negative 6x squared plus x minus 4. Okay, so let's go ahead and find the sum. We can just drop the parentheses. There's no distribution here. So we have 4x squared minus x plus 1 plus times minus is minus 6x squared plus x minus 4. Let's combine like terms. 4x squared minus 6x squared is what? So keep the 2 out. Don't multiply yet until you finish the parentheses. 4x squared minus 6x squared. Signs are different. You subtract and keep the sign of the bigger. Negative 2x squared. Negative x plus x. Those two add up to 0. And then positive 1 minus 4 gives us negative 3. Okay? And then lastly, we apply our distribution property over a difference. Distribute 2 to these two terms in the parentheses. And your final answer will be negative 4x squared minus 6. Answer to question 13 is option number 3. All right, let's take a look at question 14. It says, what are the solutions to the equation 3 times the quantity x minus 4 squared equals 27? All right, so something to keep in mind, or a quick reminder. This is concerning solving equations, okay? Solving quadratic equations. All right, so whenever you take the square root of a square, when solving quadratics, remember what? You need to remember to insert plus or minus on the root. Okay? Okay, so what are we talking about? You're going to see it in a second while we're trying to solve this problem. Okay, so we have this quadratic equation, 3 times the quantity x minus 4 squared equals 27. To solve this, first step is divide both sides by 3. Okay. And then we have the quantity x minus 4 squared equals 9. Now what we're going to do is we're going to take the square root of both sides. Now notice what's happening on the left side. We're taking the square root of a square. Okay? So anytime you take the square root of a square, you end up with plus or minus that root. So x plus or minus x minus 4 equals square root of 9, which is 3. Okay? Now, there are multiple ways we can solve this equation. We can split it at this point, distribute the signs and go, or we can move the plus or minus over. So let's do that. That's much faster. So I can divide both sides by plus or minus 1. What that is going to accomplish is that it's going to move the plus or minus sign to the right side of the equation. So you have x minus 4 equals plus or minus 3. Okay. Now you can split the equation into 2. We have x minus 4 equals negative 3. Or we have x minus 4 equals positive 3. Let's solve the first one. We just add 4 to both sides. And the answer is x equals 1. And the other one, same procedure, add 4 to both sides. And the answer is x equals 7. So the solutions are 1 and 7. option number 1. All right, let's take a look at question 15. It reads, the system of equations is shown below. So we have equation A and B. Which method eliminates one of the variable? Okay, so tip concerning elimination of variables. Okay, elimination of variables when you're dealing with a system of equations. So, in order to eliminate a variable, the bottom line is that the coefficients have to be opposites of one another. Okay, so let's write that down. In order to eliminate a variable in a system of equations, their coefficients must be opposites. Okay? Why is that? Because the linear composition of two opposite numbers is 0. They take each other out. Alright, so what we're going to do is we're going to apply these steps here to the problem and see which one results in us getting opposites in our system of equations. Okay? Alright, so the first one, let's see, we have we're multiplying equation A by negative 1/3. So equation A, let's put it here, is 5x plus 9 equals 12. And equation B is 4x minus 3y equals 8. So what if we multiply the first equation by negative 1/3? Does it result in any of the coefficients being opposites, either the x's or the y's? Well, let us see. If we distribute the negative 1/3 across 5, 9, and 12, we're going to have negative 5 over 3x. Okay, just put a 1 underneath the 5 and multiply, okay? Well, a third of 9 is 3, so minus 3y. And then a third of 12, 12 divided by 3, we have negative 4. All right. Equation B is unchanged, so that's just 4x minus 3y equals 8. The coefficient of the x's are definitely not opposites. Take a look at the coefficient of the y's. They are identical. Can we eliminate them? By linear combination, the answer is no. In order for elimination to happen, they must be what? Opposites. Okay? So let's say this was positive and that was negative, then it'll work. Or this is negative and this is positive. The signs have to be different. So option 1 is not correct. Let's try the second one. Multiply equation B by 3 and add. Okay, so all of them we're adding. That's important too. If we're subtracting, there's a totally different situation. Alright, so this is option 1. Option 1 failed us. Option 2, we have the first equation, 5x plus 9y. That's equation A. Equation B is 4x minus 3y. So we are multiplying equation B by 3. So when we do that, the question is, do we end up with identical variables that have opposite coefficients? Well, let us see. Equation A remains unchanged, 5x plus 9y equals 12. Equation B, distribute the 3 to every single term, so we have 12x minus 9y. 3 times 8 is 24. Now, do we have opposites? The x's are not opposites. The y's are, the y's are opposites of one another. Okay? So what happens when you carry out the linear combination of these two equations? The y's take each other out. They add up to 0. And you have 17x equals 39. And you can just solve this by sorry, equals 36. And then you can just solve that by dividing both sides by 17. Okay, but that's not what the question asked. So bottom line, when the coefficients of identical variables are opposites, when you combine them together, they get eliminated. So the answer to question 15 is option number 2. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions or comments about the contents of this presentation or any math question um, on the Regents exam, just post your questions and comments below, and we'll be more than glad to support you. More clips and prep resources can be found on math.serve.com. If you want to access our playlist, you can just scan this QR code. It will take you directly there, or look in the description for the link to the review series playlist. Okay? Thanks again for watching, and have a wonderful day. Goodbye.